Today I'll be speaking with Peter C. Frost, President and Chief Operating Officer of ATW Companies. He will be discussing the parts and services AT-Wall, an ATW company, is featuring at the International Microwave Symposium in Boston. Can you speak about AT-Wall's experience and expertise in the microwave industry?
AT-Wall was founded in 1886 and has become a world leader in the production of seamless cold-drawn tubing. In the early 1960s, as waveguide evolved from military applications into commercial applications, AT-Wall supported the development of new, innovative products with consistent process improvements resulting in a reputation for reliable quality and service on an international level. In today's global economy, AT-Wall is known as a premier supplier of waveguide tubing for the defense, medical, aerospace, and avionics industries. Our capabilities at AT-Wall enable our team of skilled professionals to satisfy the demanding market for state-of-the-art manufacturing, world-class customer service, on-time delivery, and quality standards that are renowned for their effectiveness in supplying original equipment manufacturers and repair and maintenance organizations.
Please tell us about the specialty tubing and metal stamping capabilities AT-Wall will be featuring at IMS 2009.
AT-Wall is featuring INVAR waveguide. INVAR has unique low expansion characteristics allowing minimal expansion in extreme cold and heat. It has the lowest coefficient of thermal expansion of all metals in the minus 273 to 177 degrees Celsius range. Microwave filters can be made from INVAR that can withstand extreme temperature shifts while maintaining the physical characteristics that control the RF signal. This means that whether the signal is being transmitted across the Kalahari Desert or the Himalayas, it will be clear. Thin-wall aluminum waveguide and seamless flexible waveguide are also being featured. These products are applicable to airborne systems and space. In all satellite applications, reducing weight means saving money. By designing systems with aluminum tubes with half or less of the standard wall thickness that have the same performance characteristics as heavier walled products, engineers can save thousands of dollars in the launch. Because it can be bent to fit to much smaller spaces than rigid waveguide, flexible waveguide also saves the customer money by reducing space. At this year's show, we are also featuring sidewall frames for hybrid microelectronic circuit packages used in defense, commercial, electronics, and medical applications worldwide. These tubular frames serve as sidewalls for hermetically sealed flat packs that demand restrictive dimensional tolerance and precise metallurgical qualities. For our stamping division, AT-Wall is featuring a base for a universal sensor. Originally produced as a machined part, AT-Wall engineers worked in concert with the customer's engineering staff to develop a stamping process which resulted in significant cost reduction and increased manufacturing efficiency. The result satisfied the demand for cost efficiencies as this product was entering into a very competitive market. Depending upon the quantity produced, the customer realizes up to 65% cost savings using the stamped part in place of the machined part.
Please define and explain for us the specific applications for AT-Wall's product and service offerings.
The function of waveguide tubing is to serve as a conduit for microwave signals transmitted from one point to another. When a device transmits a signal, the signal travels out through a waveguide tube. When a device receives a signal, the signal travels through a waveguide tube. There are different types of sizes of waveguide, each serving a specific purpose. The most common waveguide tubes are rectangular, circular, and flexible. Waveguide is also produced in a range of alloys, each alloy lending its own characteristics to the function of the waveguide tube. An example would be the lightweight aluminum waveguide for aerospace applications, to heavy copper waveguide to withstand hostile environments. Applications of waveguide tube range from the military, such as radar, sonar, satellite, and missile guidance systems, to commercial, such as medical, telecommunications, and aviation industries.
Can you discuss how AT-Wall's capabilities fit into the current, challenging economic landscape? Why do they make economic sense today and in the coming years?
In developing countries such as India, China, and Argentina, there's a push to expand and develop new communication, medical, and defense systems. RF products needed to support these systems require waveguide and other specialty tubing. Engineers create designs with the best tubing possible. These designs might include tight tolerances, very exacting surface finish requirements, and special length considerations. When the design leaves the drawing board, buyers often find that mills require the purchase of several thousand feet of specialty tubing. The cost of doing this could force a change in the design, making it less efficient, causing the customer to lose the contract. Over the years, the engineers have learned that they can come to AT-Wall in these situations. Our extensive stock of raw material and tooling enables AT-Wall to offer customers special shapes, heights, and wall thicknesses in minimum order amounts during the development phase. When the project goes into production, AT-Wall has the capacity to support full production runs of several thousand feet. In already developed countries, the current economic situation is forcing many countries to decide if they should replace or repair already existing